Mr. Stat Sensei, Mr. Sensei, and this is Classical Probability Assignment 3A.1, Expected Values and Basic Probability. We're going to break this assignment into two videos. The first video will be questions 1 through 7, and then the next one will finish it up. So it says, find the expected value, the standard deviation, and the variance. First off, when they're talking about the expected value has a couple ways to express it. It might look like find the X bar, which is the average, or it might say E of X, which is expected value. Standard deviation looks like that. And variance is just the standard deviation squared. So taking this to raising it to the second power. All right. So here we have the possible outcomes. Possible outcomes of X are 10, 20, and 30. Those are the possible outcomes. And here we have the probabilities. And another way to say probability is the frequency. Actually, relative frequency because it's a percent. Now, I'm not going to go over that on all of these, just on this first one. So relative frequency. Now, the one thing to know, to be a valid probability distribution, this is super important. These probabilities have to sum up to 1. So we should go ahead and check that out. So we're going to go 0.3 plus 0.5 plus 0.2. And they do, in fact, equal 1. So guess what? It's a valid probability distribution, and we can go ahead and proceed. So where I need to do is I need to go to Stat Edit. So we're going to press the Stat button. Edit's already highlighted, and we'll press Enter. I got a bunch of stuff, and I just go up to the top, clear it out like I always have. By now, you should be pretty good at that. So my X values, 10, 30, 20, and then 30. The probabilities associated with those are 0.3 or 30%, 0.5 or 50%, and 0.2 or 20%. So I have those in there. All right. Once I have those in there, I can actually have the calculator do all the work. I can go stat, calc, one variable statistics, my list, my X list, and that's when it's asking for the list. The X list is an L1, so blue 1. And my frequency, and I do need my frequency on today, is blue 2. All right. And that's what we said here. Oh, that's the frequency. That's your probability. Press enter, and I get a bunch of information. Well, that X bar is 19. All right. So the X bar is 19. So there it is. Our standard deviation is 7. Now I can keep scrolling, and this variance will never show up. But remember, variance is just the standard deviation squared. So 7 squared is 49. If you're not sure, here's how you do it. Press 7. I like to use the caret button and the 2. 7 squared, 49. All right. Moving on to the next one. Find the expected value and standard deviation and variance for the following. Once again, let's check to see that these frequencies actually do, in fact, add up to 1. Because all valid probability distributions have to add up to 1. So 0.3 plus 0.4 plus 0.2 plus 0.1. Hey, it's a valid probability distribution. So let's go ahead and enter this thing. We're going to press Stat. Edit's highlighted. We're going to press Enter. We're going to clear out this stuff from the last problem. And our X values are 2, 4, 6, and 8. That's the things that could occur. And the chances that you get a 2 is 0.3 or 30%. Chances of a 4 or 40%. Chances of a 6 are 20%. And the chances of an 8 are 10%. Once again, we press Stat, arrow to calc, one variable statistic. Already have L1 and L2 highlighted. If you don't, it's blue 1 and then blue 2. And we find our X bar. Our X bar is our expected value. Please don't forget that. This could have just as easily asked for the X bar or the average, and it's 4.2. The standard deviation is 1.8667. Okay. Now, I don't see, I can sit there and scroll and I don't have my variance. So I have to take that 1.887 and raise it using the caret button. It's the second power. And I get 3.561, and that's approximately due to rounding. Okay? Continuing on. Find the expected value and standard deviation and the variance for the following. Once again, let's verify, is this a valid probability distribution? And so we see, does it add up to 1? 0.2 plus 0.4 plus 0.4 is one whole. So we're going to go to stat edit, and we can get a 1. We have a typo on this one. So I'm going to pause this for just a moment. All right, even though we have a typo, we're going to go ahead and continue with it the way it is. We should not have these two values repeating, but we do. So we're going to go, okay, we have a 1 and a 1 and a 2 for the x value, and 20%, 40%, and 40%. And we're going to go stat calc one variable statistics, L1, L2, and my x bar, that's my expected value. That's what I expect to happen is 1.4. I see my standard deviation is 4898, and we have to square that value in order to get the variance. So 0.4898 raised to the second power, and we get 0.2399 approximately. Okay, that shouldn't be, this should not have been there. We're going to make a note to fix that for next year. All right. Number 4, find the expected value of the standard deviation and the variance for the following. Once again, does it add up to 1? We say it does, but let's check it out, make sure. Super important, otherwise it won't work. So 0.1 plus 0.2 plus 0.5 plus 0.2 equals one whole. It's a valid probability distribution. Well, we can have 100, 200, 300, or 400. So let's go to stat edit, clear that stuff out. And we have 100, 200, 300, 400. It's important to always put the x values in L1. It just makes life easier. And we always put the probability or frequency into L2. So 0.1, 0.2, 0.5, 0.2. Stat calc one variable statistics. Once again, blue 1 and blue 2. And we expect 280. All right. And we see our standard deviation is 8.178. We want to find our variance. To find our variance, it's not on the screen, so we have to square this value. So 87.178 raised to the second power gives us about 7,600.004. All right, let's see if I get those lights back on. There we go. Okay. So number 5. The probability model below describes the number of repair class that an appliance repair shop may receive during an hour. Another typo. This should not say class. This should say calls that an appliance may receive during an hour. Calculate the expected value, the standard deviation, and the variance. So once again, we could get 0 repair calls, 1 repair call, 2 repair calls, or 3. And the probability is 10%, 30%, 40%, and 20%. Once again, this is my frequency. Technically, it's a relative frequency. Okay, and this is always going to go into L1. We'll put those in L1 and this into L2. So let's make sure this is a valid probability distribution. So 0.1 plus 0.3 plus 0.4 plus 0.2. Oops. 0.1 plus 0.3. I guess it wasn't a valid probability distribution. Just kidding. So it adds up to 1, so that's good. It works. So we're going to go to stat edit and clear this information out. And we have 0, enter, 1, enter, 2, enter, 3, enter. This is 0.1, 0.3, 0.4, 0.2. Stat, calc, one variable statistics. Once again, blue 1 and blue 2. And we get an average, our expected value of 1.7. Our standard deviation is 0.9. Once again, we can't find variance. So to get the variance, we have to square that. So 0.9 raised to the second power. And we get 0.81. Okay, the next question, how many calls should the repair shop expect in an hour? The expected value is our X bar. On average, we would expect to get 1.7 calls per hour. So it's just, hey, it asks for the expected value. Oh, that's what we've already calculated, not anything extra. The next thing, a commuter must pass through 5 traffic lights on her way to work. She estimates the probability model for the number of lights she has to hit. She can hit 0, 1, 2, 3, 4, or 5. Okay. And the probability of each are given below. Let's verify to make sure that this is actually a valid probability distribution. Remember, to be valid, it has to sum up to what number? Yes, you're right. It has to sum up to 1. So we have 0.05 plus 0.025 plus 0.035 plus 0.15 plus 0.15. You know what? I typed those in there. 0.05 plus 0.25 plus 0.35 plus 0.15 plus 0.15 plus 0.05. And it does add up to 1 whole. It's a valid probability distribution. We're going to go to stat edit and clear out our stuff. Okay, so we can have 0 red lights, 1 red light, 2 red light, 3 red lights, 4 red lights, 5 red lights. Apparently she only goes through 5 stoplights on her way. Okay, and the probabilities are 0.05, 0.25, 0.35, 0.115. And the last one is 0.05. And stat, arrow over to calc, one variable statistic, blue 1 and blue 2. And we, on average, we would expect to hit 2.2.5. So 2.2.5, 1.259 is our standard deviation. We're going to square that value to get our variance. So 1.259. Again, I like to use this button for my square button. And I get 1.585. So how many lights did she expect to hit? Well, this is X bar, which is our mean, on average. On average, we'd expect to hit 2.25 lights per day. Okay? All right, moving on to number 7. On number 7, a consumer, hold on just a second, let me get a little better organized. All right. A consumer organization inspecting new cars found that many cars had appearance defects such as scratches, paint chips, and small dents. 21% of the car had 1 defect, 11% had 2 defects, and 7% had 3, and none had more than 3. Okay, so how many defects could you have? You could have 1 defect, 2 defect, and 3 defect. When I add those up, if I just wrote those in, 1 defect, 2 defect, and 3 defect, 21% had 1. So, okay, that's 21 divided by 100. And by the way, I know your teachers probably didn't tell you this, but always just divide a percent by 100. So 21 divided by 100, 0.21. All right. And 11% had 2 defects. Well, 11 divided by 100, that's 0.11. And 7% had 2 defects. So 7 divided by 100 is 0.07. All right. And it said none had more than 3. Okay. So how many had 0? defects. Well, first off, let's add this up. We add this up and we go 0.21 plus 0.11 plus 0.07. It's not a valid probability distribution. But I only have 1, 2, and 3. Isn't it possible that I have 0 defects? If I have 0 defects, how would I figure out what that number is? Well, these added up to 0.39. So I need to take those and go, well, it's one whole. To be a valid probability, it has to add up to 1. So 1 minus the 0.21 plus the 0.11 plus the 0.07. So let's do that. So 1 minus parenthesis 0.21 plus 0.11 plus 0.07. And I get 0.61. Well, if I did that right, that should add up to one whole. Let's check it out. So 0.21 plus 0.11 plus 0.07 plus 0.61. And it adds up to one whole. So we have the probability of one defect is 21%, two defects is 11%, 3% is 3 defects is 0.7%, and 0 defects is 61%. Now, you don't have to go in order. I know this is not in order from least to greatest. It doesn't matter. We can go with that. So we can go stat, edit, clear out all the other junk from the previous problem. And we're going to go 1, enter, 2, enter, 3, enter, 0, enter for the defects. And 21%, 11%, oops, not 11, 0.11, 0.07, and our 61%. Stat calc, one variable statistics, blue 1 and blue 2. And the expected number of defects is 0.64. Remember, X bar is our expected. The standard deviation is 0.9329 or 0.933. And standard variance right here doesn't show up. This is standard deviation. This is variance. That doesn't show up. So I have to go 0.933 and raise it to the second power. When I do that, I get about 0.870. So this is 0.933, and it's about 0.870. So how many appearance defects are expected for each car? Expected, that's our average or our X bar. And on average, we would expect about 0.64 defects per one car. All right. This concludes this video. We'll do 8 through 13 on the next one. Thanks for watching. Look forward to seeing you on the next one. Bye.